So when given an equilateral triangle, we know all sides are congruent, and you only need one side to figure out the area of that equilateral triangle. So we have the area is equal to side squared, root 3 over 4. Think of 2, 3, 4. 2, 3, 4. Okay? So add that to the formula chart. So let's move on to our notes. So, oh no, my pen. So what shape is example number 1?
Triangle.
What kind of triangle?
Equilateral.
Equilateral. So we know we can use that formula. So equilateral triangle with a perimeter of 18. Draw this figure if it helps you. And we know if the perimeter is 18, one side has to be how many?
6.
One side must be 6. And the formula that we just wrote or added to the chart was side squared root 3 over 4. And as long as I know the one side, that is enough to find the area. So we have the area is equal to 6 square root 3 over 4. Now, are we going to mess with the root 3? No, just the whole numbers.
Can I go get a coffee from my friend? She's outside the room.
But then I'm recording.
I'm sorry.
Go get your coffee. Must be very nice. Be good?
What?
Mm-hmm.
Yeah, that looks good.
No. You be good. Oh, it looks good too. Okay. Okay, what is 6 squared?
36.
36 divided by 4 is how many?
9.
So we have 9 radical 3. And our units for this one is meters what? Squared.
Wait, how did we get that radical? Oh, because 36 divided by 4.
You were on your phone.
No. I have that like written down up until 36 root 3 over 4.
We're going to move on to the next thing. Okay, what shape do I have inside the circle for the next figure? We have a hexagon. So there's something really special about the hexagon as long as we have an equilateral or regular hexagon. First of all, let's kind of look at this right triangle. And that A stands for the apothem. So let's write out A is apothem. That might be a new vocab today for almost all of you guys. So for a regular polygon, for any regular polygon, we have the following formula. Area is equal to, and for the area, make that a capital A, so the little a is going to be for the apothem. It is the apothem times the perimeter divided by 2. And let's see if that's listed on our formula chart. When you look under the trapezoid, do we have that? Now, I like it all over, so I prefer this, but they're both correct. Okay, so go ahead and box that. Now, there is a interesting fact for a regular hexagon, so I want you to write something out for me. For a regular hexagon, this item will always be true. The side will always be equivalent to the radius. And if I were to elaborate that, I want to look at this triangle specifically. Would you guys agree that from the center to the edge, it's basically the radius of the circle?
Yeah.
And then only in a regular hexagon, we have 6 equilateral triangles. So therefore, the one side is equivalent to the radius. So let's write on here, side is equivalent to the radius. And that is only true for the regular polygon, all right? So let's look at example 2 on the bottom. We're looking for the area. So here's what I can do to make my life easy. Make yourself an equilateral triangle. And notice that we have the side of 4. Now, when given an equilateral triangle, didn't I give you a formula initially?
Yes.
But once I apply that formula for the equilateral triangle, what must I do to find the total hexagon?
Multiply by 6.
Multiply by 6. Very good. So let's write out there are 6 congruent equilateral triangles embedded in the regular hexagon. So we have area is equal to side square root 3 over 4. So then when I plug it in, I get 4 squared over 3 over 4. And if I were to simplify just the whole number, 4 squared is how many? 16 divided by 4 is how many? So I have 4 radical 3. But that's not the area of the regular hexagon, so I need to do what at the very end? 6 times that area. And just simplifying the whole number, what is 6 times 4? 24, radical 3 centimeters squared. Let's see why that was easier to do, in case you're like, well, why didn't you use the other formula? So this piece, just watch. Y'all ready? If we know we have to use the apothem times perimeter divided by 2. To find that apothem, I have to use special right triangle, the 30, 60, 90. That is way more step in between, okay? So when I do give you the apothem, you're forced to use it. But if I give you a side of a regular hexagon, this will be the easiest method, okay? We'll do one that's gonna work with the apothem on the back, hopefully. All right. So on the back, Romer, let's read.
Find the area of a regular hexagon, 442.
All right, is this pretty similar to the previous one?
Yeah.
Okay, let's try this one with the partner. Talk to your neighbor.
Miss Brooklyn, where's your pencil sharpener?
All the way down by the file folders. You see it? Okay. It's okay. I'm here. It's okay. I won't leave you. How many is one side of this regular hexagon? 7. So do you want to worry about finding the apothem, or can we just use the equilateral and times 6?
Times 6.
Equilateral and times 6. And when you did, I'm going to actually get to the final, and if anybody want me to go back, I can. We have 6 equilateral triangles in a regular hexagon. You should have gotten 49 radical 3 over 4. So let's talk about how much further we need to get to. This question, by the way, is very important. We all know what that means. So, just by looking at this, we need to go ahead and simplify out the 6. By simplify, I mean further elaborate. The 49 and the 4. So let's see how we can actually go about that one. Let's put 6 over 1. And I think I want to write this off to the side. 49, maybe in parentheses. And I have 1 and 4. Is there a number on the top and the bottom that I could further simplify to make my number smaller?
Yes.
6 and 4 can further go to what?
3 and 2.
3 and 2. So then that's going to give us 49 times 3. How many is 49 times 3? 147? Does anyone want to see 147? Divided by 2. So the way you can write this will be the following. You can write the area as 147 over 2 and keep the radical 3. Or some of you guys might like the mixed fraction to see how many wholes can come out. So 147 divided by 2, how many can come out of that?
73.
73. And then we have 1/2 radical 3. Of course, it should be feet squared. So I will take both the answers. So whether you have it improper, as long as the fractions are simplified, or mixed fraction, I kind of prefer the mixed fraction because to me the whole and the partial makes more sense. What's
Can
up?
you write it as a decimal, like 73.5?
You can. Since the 0.5 is actually clean, I think I'll be okay with that.
Okay.
But if it were to be on a quiz, it'll tell you what format it wants. Okay? All right. Let's go on to example number 4. Do we remember example number 4 from the other day? The big minus the small?
Yes.
All right? So my big circle minus a small circle is going to give us the shaded region right in between. So on my big one, we have pi r squared for both of them. What is the radius of the big one? Pi 9 squared. And then the radius of the smaller one must be how many? 6, because if the whole thing is 9 and that outside surface, the ring is 3, we get pi 6 squared. So that's going to give us 81 pi minus 36 pi. So how many pi's do I get? 45 pi centimeters squared.
That's a lot of pi.
I know. Lucky you.
Wait, if
Mhm.
you're subtracting 81 pi minus 36 pi, since it's 2 pi's that you're subtracting from each other, wouldn't it just be 45 centimeters squared?
Oh, let's look at that algebraically. Back in algebra 1, when you were told 81x minus 36x, wasn't that 45x?
Yeah.
So you carry that extra along with you.
Okay.
Okay? So let's go on to example number 5. On example 5, yes ma'am.
Where did you get 6 from? Yeah.
If this whole thing is 9 and this partial is 3, then the smaller one must be 6. All right. Number 5 says to find the area of a regular hexagon with the radius of something. So let's see what we wrote on the front. Only in a regular hexagon, what do I know about the radius? It's the same as a side, okay? So if you want to say the side is that value, that's perfectly fine. So given the regular hexagon, what's the trick that we can use instead of using the apothem?
Equilateral triangle.
Equilateral times 6. Let's do that. Area is equal to, I'm going to start with the equilateral triangle. And we know the radius and the side are congruent for the regular hexagon. So my side is 8 squared over 3 over 4. And if I were to simplify further, what is 8 squared?
64.
What is 64 divided by 4?
16.
So 16 radical 3 is just the equilateral triangle. So I need to take this and multiply by 6. And that's going to give me 96 root 3 feet squared. So far we were able to use our trick with the equilateral triangle for the regular hexagon. The next one, I'm going to show you if that's not given. All right? So it's going to be a lot of work. So bear with me. Josh, go ahead and read example number 6, our last problem.
If the apothem of a regular hexagon is 5 centimeters, find its perimeter and area.
All right. Let's draw a regular hexagon. If y'all remember me drawing this last year or last semester, it was as if you're making a rectangle and put a dot on the left and the right. It's going to complete, possibly, as a regular hexagon. And then we want to make the apothem down here. That is our apothem that is perpendicular to the base. So right now, they gave us the apothem is 5 centimeters. So I'm going to zoom into that right triangle really big so I can write more things in it. So this right here is 5. So my goal is to figure out what is that one side. Now, to find the one side, since we have an equilateral triangle, although it looks like an isosceles, if I find this side, isn't that the same on this side? Which is the same on the base side as well? So I'm going to go ahead and focus on this one right here. So let's highlight that piece. If you want to write the x on the right side, that's okay too. And in an equilateral triangle, we know we have what angles on the top? You know that's a right angle.
40.
If I know all the way around is 360 degrees, isn't there 6 congruent angles for the hexagon? Yeah? So we know it's got to be 60 degrees all right here.
So it's 30.
So this has to be 30. Then I know this is also 60 right here. And that's going to be a given fact of 30, 60, 90 for every hexagon, every single regular hexagon. So let's go ahead and write out our proportion. We have x over 5. And as a reminder, let's write 30, 60, 90 on the bottom. So 30, 60, 90 had a ratio of 1 root what?
Root 3.
And 2. Very good. So x is opposite of 90, so I need 2 right next to it. What about 5? What number needs to be next to the 5? Radical 3. So when I go ahead and further cross multiply, we have x root 3 is equal to 10. And we're going to divide it by root 3. And we're going to have to, in the end, do what? What was that word? Rationalize. So that's going to give us 10 root 3 over 3. I wonder why I have this piece on here. Okay, got it. So let's write out the area formula that has to do with the apothem. Times perimeter divided by 2. So we know, just by looking at this, we know the apothem is how many by the given? 5. Now I need to figure out what the perimeter is. So let's write the perimeter off to the side. So if I know that's one side, how many of them do I have for the perimeter?
6.
So let's write 6 times that one side. And that alone is going to give us 60 root 3 over 3. Can I further simplify 60 root 3? 60 over 3, I mean. 20 root 3. So just for the perimeter is 20 root 3. It's a little jumbled. I should draw like a line here. Divided by 2. So let's simplify the whole numbers alone. If I take 5 times 20 divided by 2, how many would that give us?
50.
So area is equal to 50 root 3 centimeters squared. So the only ugly thing is trying to figure out which special right are we going to use. But for the regular hexagon, it's almost always 30, 60, 90. Okay?